So, hi everybody, I'm Odin. I talk too fast and screw things up. Hi Odin. You're a terrible self-help group, but I'll tell you all my problems anyway. This is my first CppCon experience, so I went to Twitter to figure out, like, what do people want to see there? And apparently you people like practical examples and jokes. So I hope the fact that mine aren't funny don't get in the way. It's your fault, Twitter. So my object lifetime began in Oregon. You know, I was allocated from a pool of hippies. And yeah, you know, growing up as a hippie kid is actually pretty cool. I had highly suggest it. It's just, you do run into a lot of the problems that you also have in software. Like if you look at, you know, all hippies want to save the world, right? They're very highly motivated, but they use the wrong tools. And it reminds me of, there's this Spanish story of Don Quixote, the knight who went crazy and started fighting windmills because he thought they were monsters, right? And this is, you know, very representative of how I sort of perceived all the hippies trying to save the world around me as a kid, because it was like, yeah, I admire your effort, but you achieved nothing, and now my windmill's broken, right? And so, you know, my view, and still to this day, was, you know, if for a thought experiment, you were to, you know, clone the world and roll back technology 300 years, because they used JIT then, right? And then ran it, your integration test would say like 95% of the world died, right? So if you think about it that way, being a nerd is probably the most philanthropic thing that you can do with your life, right? And so obviously I became a nerd, because in Oregon, either you become a nerd or a lumberjack, and I just don't have the build to be a lumberjack, right? So I started as an electronic engineer, and so I did the stuff that all electronic engineers do, and that's writing software, just not for normal systems, for tiny systems. And I'm completely self-taught, and I kind of mapped sort of how you teach yourself things if Google is your only source. And this is kind of the being innovative and teaching yourself development cycle, right? Think of something, then you implement it, and it turns out to be way harder than you thought, and you turned out to be very, very wrong about it, but still you work on it really hard, and then you show your friends, hey, look at this cool thing I built. And they're like, you didn't think of that, did you? And it's like, shit, right? And then, you know, you try and fix it, and then while fixing it, you get another idea, and then you go back and around in a circle. So what are we talking about today? Well, in C++, we have this concept of you don't pay for what you don't use, right? And this is actually a perfect throwback to nerds or philanthropic. This principle that we have has saved more energy, more resources than the entire hippie movement and probably most governments, right? This is awesome. The problem is we don't always do it, right? Who here has shared pointer in your code base? Like everybody, okay. Who here has a shared pointer in your code base that is not standard shared pointer? Yeah, still most people, right? That's kind of the problem. Like there are very, very many reasons why you'd have your own shared pointer, because, you know, shared pointer is essentially, you know, the committee sat around a big can and started throwing design decisions in there. You know, okay, there are cyclical dependencies. Well, that's dangerous. Why don't we throw in something to stop that from happening, right? And oh yeah, they're going to be used multi-threaded. Well, you know, make things atomic, and so on and so forth. You know, for the common case, for the use case that everybody, or at least the theoretical everybody that nobody is, needs, right? So if we want a shared pointer that's only going to be used on one thread, then we don't need this atomic ref count. It could be non-atomic. And if we have a shared pointer that cannot cyclically depend on things, we don't need weak. In that case, it's not a performance overhead, it's a memory overhead. because we don't need the counter of weak pointers, right? Maybe I don't need a custom deleter, or maybe I need a custom deleter, but I don't care if that infects my type, right? Maybe this use case of shared pointer is not a vocabulary type. It's not being passed through a million functions, not even all of which I'm an author, right? Maybe it's just in the private section of my class because I need to do copy on write optimization or something. Why can't I make allocator, deleter, whatever part of my object? Or maybe I don't want you to give me a naked pointer because make shared is more efficient. Maybe I want to force you to always use make shared. Maybe I want the objects that you allocate to all come from a certain pool, right? There are many, many, many variations of design decisions which you would want just a slightly different way. And the problem is, if you just take and throw those design decisions into your own can, you not only get those design decisions in that can, there will be a huge amount of bugs in there too, right? If you try and implement yourself, you're going to screw up. But what if we were to, decompose a shared pointer into its pieces, right? And this is kind of the pieces I came up with after thinking about it for 10 minutes. This is probably not the optimal set of features that's in shared pointer. But like, could I do this? Could I make this syntax work so that I could make my own shared pointer with less of these things, throw out all the stuff that I don't need, and then I could have my can with just the stuff I want in it, but no bugs, right? So this problem, we find this problem in a lot of code, and so I've in my domain it's bare metal drivers on microcontrollers, but I can't talk about that because it's one of the examples. It was the only example no one would come, right? So I tried to find examples from other domains so that if you understand any of these, it will work, right? So you don't have to understand all of them. But keeping to the standard library, we have standard function where we also want to maybe take things out of the interface, right? Or we maybe want to want small object optimization in standard function, right? Maybe we want to. We do have small object optimization. We just can't rely on it on being any size because it's not specified, right? So if I wrote code that's performant because my objects are small, maybe some future STL will make the small size object optimization not a little bit more small, and then it all goes to heap, right? So if there is a proposal in the SG14 for in-place function, which is basically function with a few more efficient design decisions and a small object optimization. There's also an in-place vector, as far as I know. There is in-place string in flight. This is another. This is a problem of fighting an exponential, as in the possible properties that we can put together into one can with brute force, and that we're trying to find all of the possible combinations which are interesting and making one of each, right? I don't know that this is going in the right direction. Speaking of not in the right direction, oh no, I didn't say that. Qt. With Qt, we have actually very high sort of compositional power, and we can in Qt we can actually quite easily go in and change things, take things out, put things in. The problem is they made it generic through virtual functions, right? So if we look at this dialog, this could be any widget library dialog. They all work somewhat the same if they're widget-based. We have in this dialog a layout, right? So we got lower layout pane, upper layout pane, right? And then in the lower layout pane, we're going to have a horizontal box layout with a pane here, which is a stretch, which basically takes up all the empty space. And then we have a button and another button. In the upper one, we have some grid layout with 4 panes, and then some of the panes we have more dividers, and this is essentially probably a composite widget, which is basically a wrapper around 2 widgets, and all the events get forwarded. And so, how this works is from an event handling standpoint is the dialog tells the topmost widget, what events came in, and it propagates them to all its children. They propagate them to all their children. They propagate them to all their children. So if some event comes in, there's going to be something like 100 virtual calls or something just for this dialog, and propagating from the root out to the leaves where the widgets may want that information. But depending on what that information is, maybe all 100 or maybe 98 of them don't care. But the optimizer can't take it away because they're all virtual calls, right? That's the reason why in Qt, key presses don't propagate like resize events. You have to go through a completely different information channel, which sucks from a usability standpoint, but it would just be too inefficient if your program ran, maybe not just this dialog, but maybe, 1,000, 10,000 virtual calls every time you pressed a button, right? On the other hand, this is all known at compile time, right? Like what fonts the system supports, that's runtime, but like the whole layout is just compile time, right? So why can't we make this dialog work at compile time? There's also another thing going on here. If you change one of these selections, or if you type text in here, this has a signal slot mechanism wired up to that, and that's got a signal slot mechanism wired up to that. So whenever something changes, it's updated on the other end, right? This again is going through many, many virtual calls to get there, whereas we knew at compile time what's connected to what. So if we wanted to, this is just vaporware. I didn't write a Qt and invest, man decades, but from a public interface standpoint, like, can we make an interface that preserves all the compile time known information and allows us to, under the hood, build the thing at compile time and wire it up the way we want it to be wired up? And this is familiar syntax, right? It doesn't look like we're feeding a TMP monster, right? This is familiar syntax, familiar semantics. You shouldn't feel the knife going in, right? No. But this is probably the third time I've mentioned TMP in this talk. So what is TMP, right? So there are two ways of understanding TMP for this talk, right? I'm most known for my TMP talks from other conferences. Those you have to understand TMP. But here, either TMP stands for template metaprogramming, which is a Turing complete general purpose code generator that runs in the type system, or TMP is Tabea, Marie, and Paul, 3 magical unicorns that live in the compiler and do whatever I tell them to do, right? That's obviously a lie, but they're actually both a lie, because Turing complete, with endless resources, right? But that's kind of how the world works, right? Like, you get born, your parents lie to you. Well, they call them fairy tales, and then you go to school and they tell you better lies, and then you go further through school and they tell you even better lies, and then when you get through academia and through your career and you're the expert in the world and nobody is better than you, at that point you can only lie to yourself. So there's a metaphor, and I'll explain things in maybe the one or maybe the other, but both understandings work, right? So let's get to embedded drivers. And like I said, you don't have to understand embedded drivers. Just this is step 7 of a 17-step tutorial of how to write Hello World on an ST microelectronics device. And it's from ST Microelectronics. It's not some guy that made this like super bad. And this is a different design decision. This is how design looks like when you decide that extra byte of RAM or that extra instruction cycle, we cannot pay for that. So it's customizable because they just spill all the guts out into the public interface, and you have to go picking through these, complexly dependent guts that are probably also poorly documented, and all in the name of efficiency, right? But in this Hello World tutorial, everything is essentially default. Like, this is the inherent complexity, right? I mean, if you don't know what a UART is, it's a subcategory of serial ports, right? So we're using UART1. We're using a blocking interface. I don't know if you noticed that on the previous slide, or maybe it was one of the other 17 steps, right? But yeah, we're using a blocking interface. We're using 9600 baud. We're using 2 specific pins, right? So this is a factory that builds me a UART driver, and I can just say blocking send, blah, blah, blah. And now I have 16.5 pages to deal with the fact that I'm going to starve something because I'm blocking call to a slow UART, right? So I've been trying to make this kind of interface work for a long time. Like this is a photo that my wife took of me 2 years ago, and she's good with a camera. Very, captures intent very well. So I was trying to make this interface work, and the tool I was using was policy-based class design, right? Alexandrescu's method of decomposing classes into policies and them working together. And so on the map, we're here, right? So I'm working on this, and I'm noticing this is hard, and you have this glue code of this policy depends on that policy, you need to be able to call it, but maybe that policy doesn't exist because these 3 others could be there in its place, and it turned out to be just this huge template monster. And but I did get some drivers working, and it turns out C is not that efficient, right? Like if you do C++ to the extent that the syntax allows you, I mean, I had something like 10x smaller flash footprints on some of these things compared to the ST microelectronics library, right? And saved some RAM and faster and blah, 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 and statically checked. And so at the EMBO conference, I mean, this is kind of also a recurring theme. Like, in the middle of creating my template monster, I was running into the problem that template metaprogramming was too slow, and max recursion depth on templates was bad in the algorithms I was using. And so I kind of like fixed that by writing a new template metaprogramming library that's way faster. And I also wanted to go to a conference about modern C++ on microcontrollers, and that didn't exist, so I founded one. And so at EMBO, I was showing this to other people, like some of the top TMP guys, like Gil Dawes or Joël Falcou or Jackie, and it's really a good thing that Joël Falcou is just brutally honest and will tell you things, because he told me, Odin, you screwed up, no one understands your code, and you won't either in the future. So I was here, right? And he was right? I mean, it was kind of a feeling of gallopy, 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 bam, windmill, right? And this is an expert from my code. You don't have to understand this because I don't anymore either. But here's an artist rendition. He got pretty inspired by that. Good thing it inspired someone, right? But here's the problem. I was making this toy, right? This is essentially a policy-based block device, right? And you have some form, some interface that this thing is to fit in, and when it fits in there, then it works. So you can swap these things out. And it's kind of under the guise of a generic thing, because on some level, it's a hexagon, right? And you need this glue code around it to make things work. But there's still a whole lot of stuff that you can't make work in policy-based class design. We basically need Legos, right? Because you can build anything out of Legos, at least the old Legos. The new Legos, you can just build like one scene from Pirates of the Caribbean. But I'm going to gripe at that in some other time. So I need old Legos. I need to be able to do things that I can't do in policy-based class design, like have an optional policy or have a variadic pack of policies that are all the same type, and I still need to call member functions of each of them in succession, or things like this. And I didn't really have names for this in the past. I've named things completely wrong because I just suck at that. And so I decided to steal some names. And so there's this discipline in academia, I don't really get it, but they think like, if all this engineering work was done, what could we do? And so this is like a self-assembling assembly line, where you have like, a robot arm that knows it needs a conveyor belt to move things, and you have like a metal stampy thing that knows it needs a conveyor belt to get stuff into it. And so all this machinery knows its capabilities, knows its requirements on other machinery, and you give it some abstract thing to build, some concept of a thing, and it will self-assemble and build it, right? So apparently some scientists have figured out how to hack this, right? So they implement it just to the point where you don't yet realize you're an idiot because it still works. I think there's a word for this, like PowerPoint or something. And then they leave all the looking like an idiot part up to us engineers, right? And I mean, I look like an idiot anyway. So yeah, anyway, so this is agent-based class design, right? This is Agent Smith. It's a good agent name, and it's not a complete set because we represent abilities with balls and we represent requirements with sockets, right? And so we have 3 requirements that are not fulfilled in this set, right? For it to be a valid set of agents, because you can build anything with Legos. It doesn't mean that it's a good thing, right? You need some way of knowing whether or not this shared pointer will work, right? This combination of properties will work. So if we have this combination of agents, then we can see that for every socket there is a ball, and we got a couple extra balls, so we have extra capabilities. That doesn't matter. Just all the requirements have to be fulfilled by other agents in the set, right? And UML is another metaphor for PowerPoint, for everything works in UML. So let's see if this works in code. So we're composing these 3 agents, and then we want to do what agents do, right? So the problem is that all 3 of these agents are capable of ass kicking, right? But we want to have one public interface function, right? And we also don't want to see a lot of the internals of these agents. We don't want that leaked into the public interface. This is a classic problem with policy-based class design, that in order for them to talk to each other, they have to have public interfaces, but that leaks into the public interface of the entire object. And Alex Andrescu acknowledged this in his book, 17 years ago, and nobody's really fixed it yet. I mean, there are hacks to make that kind of work, but it's still a hard problem. So the way I try and solve this is, in concept, all of the agents are in their own arena. They can talk to each other, but nobody outside can talk to them. And then we have public interface classes, which can be composed, so you can have multiple of them, and they can add to the public interface, and they can also access the agents, either by type, like give me agent type this, or by ability, as in give me all the agents that have this ability. So this is an agent, right? Basically everything's an agent. An agent has to be, I guess it doesn't even have to be movable. I don't think there's really any requirement on agent. This agent, if we put this agent in our arena, it wouldn't add to the public interface, obviously, and nobody could find it except for by type. And that's not really how this paradigm works, so we need to associate abilities with this agent. And we can either do that by specializing traits. There's a specialization of a traits class. Basically, we're telling the unicorns, Mr. Smith, ass kicking, that's a show, right? So this is one of the ways of associating abilities with agents, and we'll see some other ways later. But if you're a library designer, this is probably what you're going to do. Like if you're designing a toolbox for building a shared pointer, then you would be giving the custom deleter the custom deleter ability, right? And the user wouldn't even have to know that that's a thing, right? So there's not a lot of TMP here, right? Okay, you just have to be able to specialize traits, and later we're going to find out a better way to do that. So what about in the public interface? The public interface does have one requirement. You have to take one template parameter and derive from it. And besides that, you don't have any other requirements on a public interface. Probably shouldn't be stateful, but the world's not going to end if you have state. It's just stupid. State goes in the arena with the agents. And you get for free functions like for each or optional or whatever in order to interface with agents. So I can say for each fulfills ass kicking, give it a generic lambda. This lambda would be called for every agent that fulfills this, that has this ability, and I will be passed a reference to that agent, right? Every interaction with agents starts in the public interface, right? So public interface gets called, and then it delegates that to agents. Can do work, probably doesn't do a whole lot of work because it doesn't have state, probably mostly just delegates to agents. But agents also need to be able to talk to each other. So, agents don't just kick Neo's ass, they also talk weird to each other, right? That's kind of the other thing that they do. So in this case, we want to delegate to an agent, and that agent should then be able to find other agents with other abilities that it depends on, right? And so in this arena, this agent needs to be able to access other agents. And we have this for each in our public interface, and to be able to make the agent be able to use for each, we have this factory function agents, which gives us a bowl of unicorn soup, or however you want to picture this thing. It's basically a pointer and a lot of template information, right? And we pass that in, and it can pass that on to other agents and find other agents that way, and just keep passing it around until you reach an agent that has no requirements for that to fulfill that ability, right? So we don't just have the for each case. We also have we also have the optional case. I need 1 or 0 of this agent, right? So if he wants to complain to his buddy about life, well, maybe his buddy's not there, so maybe we need a fallback, right? So you can also pass in 2 lambdas, and the first will be called if there is an agent. If there isn't an agent, then we can fall back to the second. And since this is a generic context, this is not fully evaluated unless you actually get stuff passed in there. So this works. We could also say we want exactly 1. We could also, rather than indexing by ability, we could also index by concrete type, as I mentioned before. But I mean, you could get cute with syntax and say, okay, well, if I want only 1, why don't you use square brackets, put this in the brackets, and you're indexing into the agents. I don't care at this point. It's just trying to make the underlying backend work. So we still haven't seen a lot of terrible TMP, right? This is kind of the user interface, and it's better than most boost libraries as far as angle brackets go, right? So this compose function that was composing the agents, well, it's also not super complicated. All that we're doing is taking a variadic pack of arguments, putting them in a tuple, and initializing a composed, some class named composed, with all the type parameters in its type list, and initializing it with a tuple. This could be a constructor in C++17. Since the library is 14, I made it a factory function called compose, and then there's a composed, which is the concrete type. So let's look at composed. Well, this is where some of the magic happens, right? Like if we see here, we're deriving from, something, right? And this something, we're telling the unicorns what to do, right? This is the so-called unicorn call syntax. You can spot unicorn call syntax because they don't use the nice round brackets, they use the pointy horn brackets, right? And what the unicorns are doing for us is they're making this class called access, and this class called access is templated on the top level derived type, right? So this is curiously recurring template pattern, if you're familiar with that, right? If I know my this pointer, and I know the type of which I am a base, I can cast from base to derived as a static cast. And then I can do stuff with that. But this is actually a slight variation because we're taking this access and we're passing it as the first template parameter to the first interface class that we have. And remember, they derive from their template parameters, right? So access is then the base of that first interface. And then we're taking that type and passing it to the second interface. And so that derives from the second interface, third interface, and so on and so forth until we get all the way up to the top level is composed. And so these functions like for each or optional or whatever, there are protected members of access. So all of the derived classes can access them. And it bubbles all the way up to composed, where we make them private so that somebody deriving from composed can't access them anymore, right? So when we want to talk to agents, we call these functions that are in like the super deep nested base class. It has the type of the derived class, can upcast the pointer or downcast. I can never remember which way it is. Anyway, to the derived class. And then it's also a friend of the derived class, so it can access all the agents which are in this data member variable, right? So it's an aggregate rather than deriving from the actual agents, which means that we can have multiple of the same type, right? Which we couldn't under policy-based class design. It also means that a lot of the other problems of policy-based class design, like you can't trivially derive whether you are copyable or not. And here, tuple does all the heavy lifting, right? Or movable or whatever, right? So if we look at, there's some stuff left out here. So let's look at that. And this is a little bit, templates view. But basically what we're doing is we also want to support another case that you can't support in policy-based class design, and that is, what if I have an agent, which is an arena allocator, and other agents that want to allocate into that allocator upon initialization, right? So I construct this set of agents, and I want some of them in this construction to go allocate parts in this arena allocator, right? I mean, this could be a small size object optimization buffer, right? And with policy-based class design, you can't really do that because you can't traverse this set of agents, because you do that with the type of the policy combiner, like the most derived type, and it isn't done yet, right? It's done at the end of the definition. So and the point of instantiation of a constructor is like now, so you can't use that trick either. And so if this unicorn speak is confusing you, don't worry, it just works. Okay? In this case, it works because data is done initializing here, right? It's valid. And so here we can obviously for each on this data. We can, you could go crazy with Hannah on this. It doesn't matter, right? It's done. It means that we're doing two-phase initialization, which is suboptimal, right? Because there are three numbers. There's 0, 1, and infinite, right? So you don't want two-phase because that turns into n-phase. But it's the best we can do, and I think it works with a lot of examples. So run with it, right? So let's look at some concrete examples that are less complex than shared pointer, because that would be more than the rest of my talk, right? So I had this problem at the office. We work on microcontrollers, as I mentioned, and somebody came to me and said, okay, I want to convert a string to upper. And this is C++, so I Googled it because, it's not like, yeah. And so the top hit on Google and the most upvoted Stack Overflow answer was use boost to upper, right? But I'm getting this weird linker problem, right? And I've never seen this before, right? And it's kind of a new guy, so yeah. So I go and look at it, and it turns out the linker problem was it didn't fit on the chip, right? He was basically doing hello world with world to uppered, and that didn't fit on the chip, neither in flash nor in RAM. And the thing is, like, if you just comment out the boost part and leave the string in there, that uses maybe 5% of RAM or something, and the rest should use 0 RAM, right? Like, to upper shouldn't be in allocating anything, right? But this pulls in enough stuff that has like static member variables, static variables in functions, and just all sorts of crap that then gets linked into. I mean, 4K of RAM is a tiny chip, so boost wastes 4K of RAM on pulling stuff in from libc. Nobody cares, right? Because it's only done once, right? Once you pull in all the crap from libc, you've got all the crap from libc in, and that's that, right? But again, it's this problem of customization points, of not paying for what you don't use, and so on and so forth. Because really, like on a microcontroller, where you're not going to be like formatting an MQTT message in Turkish, which is where 2-upper kind of gets complicated. You basically just need ASCII, right? And okay, maybe you do want to potentially support Unicode, because I make an agent that does 2-upper on ASCII, and then you, Swedish guy, can put all your funny letters in there, make a second agent, and we'll just make a public interface thing that just runs the one and then the other one, right? And yeah, I mean, then I guess I'm proud that German is one of the languages that is no longer funny, because we have a big version of our Est-set letter, as of, legislated as of like 6 months ago. So that's going to break libc. Why is that in libc anyway? Yeah. But we also want to use Unicode, and with Unicode you could have like a uppercase letter that's 4 bytes that maps to a lowercase letter that's 1 byte, and so it gets a little more complicated. So why don't we just make a more generic interface where you basically have 2 ranges, input range, output range. We eat things out of the input range and then convert it and spit things into the output range, and then in case you want to have a prioritized set of them and multiple could match, we also return true or false whether or not we found something to eat, whether or not we matched anything, and then make a public interface class that just does a for each until one of them returns true, and then a for each again until one of them returns true, and does that. And if this is a very generic, powerful interface for dealing with text. Like if you give this to Ben Dean, he'll make a toaster for you at compile time, right? So, I mean, we can do like trivial string formatting with this kind of thing, right? I make an agent which walks the string and looks for curlies and then goes through the agents in the set. I mean, I'd have to write some kind of filter and then index, because for each wouldn't cut it anymore. But I mean, I could write a string formatting library where you can control everything that goes into it, right? And that's, the Linux community likes this saying that any feature you can't turn off is a bug, right? Well, why don't they apply that to their C library, right? So with these tools, can we express this in drivers? Right? Can we build this driver and make it work? Well, yeah, I mean, all we have to do is, make this an agent, and make this string literal return an agent, and make this statement return an agent. And yeah, we have an array of agents that can rely on each other and whatever. And if, maybe I want stop bits, right? Because I'm talking to some ancient machinery or whatever, or maybe I want 2 start bits, or all the other weird things that are just here by default. Well, I can drop those in, and then they're agents and are found and are used. And in whatever function may rely on that, I will just optional that agent. And so if the agent is missing, then I'll just do the default, right? And if I have some special functionality to my UART, I can also add to this canned set of agents by making my own agent. There's this thing called Autobot, where you can tell some UARTs, okay, just look at the communication, measure bit widths, smallest thing you measure, that will be the baud, right? That will be, and so you can say, okay, baud may have changed. Next byte you see, check out what the baud is, right? So we need to add this to the public interface so that we can do that, right? Then we also need to test if the baud rate has been set, and we also need to, in the interrupt service routine handler, we may get an interrupt, hey, I got a new baud, right? And this is where we can really beat C, because we know things in our code generator at compile time that the optimizer doesn't know. The optimizer doesn't know that this 1 bit in this special function register says calculate an autobaud, and when that 1 bit has been set, then this other status bit that happens in this interrupt service routine can never be true, right? If I didn't say set autobaud because it's not part of the public interface, then that branch in the interrupt service routine handler can just be removed because it will never be called, right? So we know more than the optimizer about this particular piece of hardware, and we can reflect that in our template metaprogramming library. Pretty simply, right? User puts in an agent, user doesn't put in an agent, right? And in the handler, I mean, just, yeah, we have to handle everything. So that's kind of the basic concept that I've, more or less is relatively young, relatively, proof of concept-y kind of a thing now. But looking a little bit into the future of where this is going, when you go this generic, right? When you start decomposing all of your objects into discrete design decisions, and then composing them in together again into some valid set of things that makes you an object that you want to do, you have the problem with vocabulary types especially, but many types that you have unexpressible types, right? Like in the examples so far, we've used auto all the time because that type is probably, potentially 1,000 characters long or something, right? Because all of the template information is in there, right? That's where the unicorns store all their stuff, right? So one way to combat that, I mean, we're, in the Qt example or in many examples, there is type erasure on the inside, and even in shared pointer, there's type erasure on the inside, right? Like the allocator and the deleter and so on and so forth is type erased, or in standard function, it's type erased. So we've created this super efficient optimized type that the compiler can see through everything, well, where the compiler can see through everything. But maybe we do want type erasure just Sean Parent style, like from the outside. So we want a type erased wrapper around the outside. And we have an interface. We have a public interface. We would have to add a few things to that in order to build a composable type eraser wrapper in TMP. And I'm stealing these ideas from Gasper's liberased, because that's basically what he does. He made a composable type eraser wrapper generator thing, and so this is possible, right? So we could make like an erased interface, and anything that fulfilled that interface, any other composition that fulfills that interface can go in there, right? And it can have extra stuff. Who cares, right? So coming back to the statically linking widgets, right? The Qt dialog, right? Could we model that? Well, if we say, okay, anything is a widget if it has the widget public interface, and a widget is probably just a composition of widget properties, then things like the HBox layout would be a box and a bunch of child widgets, right? And an interface, and maybe some event delegating, and so on and so forth. And so these would then be factory functions. So let's look at one of these factory functions. So here we have VBox layout, and we're taking all the widgets that are our children, and we're associating some abilities with this composed object, right? So rather than specializing traits, we can also embed a list of abilities _t, which this variable template will build for us, as the first template parameter of the composed object, and the traits class looks for that, is specialized on first parameter is a list of abilities t, and then we'll look in that list if the ability in question is in there, and then resolve to true if yes. So this is another way that we can associate abilities with agents, because now a composition of agent can itself be an agent in an upper nesting level of composition, right? So we can arbitrarily nest them as deep as we want. And so we can make this widget thingy work. Now, what about the signal slot mechanism between the box and the text field, right? On change, it wants to update the other one. Well, there are two ways to go at that, and one I don't have time to explain, so I'll explain the other one. So if we assume that everything that comes in as stimuli, as in somebody clicked on it or somebody changed it or whatever, goes through the event system, then what we could do is take, in the top level widget, we could take that bowl of unicorn soup that had all the type information. That not only has all the type information for that composition, but because all of the nested compositions also go into the type information, that bowl of unicorn soup has all the information for the entire hierarchy, and it is a pointer to most derived. If you have a pointer to most derived and all the type information, you can walk down, you can say, okay, I am a widget deeply nested on this branch. I can say, hey, I'm a publisher. I will look for people who subscribe to my messages. Walk the whole tree, find everyone who's subscribed, and call them directly, statically linking without any of this any of the virtual calls and whatever that go with the signal slot mechanism. And you know, when I was working on Quasi-RMPL, my template metaprogramming library, people were making fun of me for benchmarking up to 8,000 types in a list. And this is why you may need that at some point, right? Like we don't have examples now because nobody, like doing that now would take you all day to compile on Boost MPL. Well, probably longer than that. But if it can compile in, you know, seconds, then it suddenly becomes viable, right? So we essentially have a poor man's reflection over a hierarchy in C++14, right? And so you could, I mean, you could, for example, write a really awesome JSON parser, right? Or you could make descriptions of your objects in the form of agents and then nest them the way JSON does. If you, as in the case with microcontrollers, have a known set of input-output objects, then you can serialize and deserialize them in far, far less code than any of the JSON libraries. And you could even potentially do it lazily, so the output string never actually even has to live in RAM. You can just dump it into some sink like a serial port, and you get rid of the problem of the unknown buffer size, because usually we don't have a heap on microcontrollers. Right? So can we solve shared pointer? I haven't made a reference implementation yet. I probably should, but I think we can decompose most of shared pointer into these agents. It will compile to essentially the same binary. Problem is, the public interface, I am constructing a shared pointer. How do the unicorns know that this pointer to something should go into that agent, right? You know, the constructor is a problem. And this is not just a problem for me here. There's generally a problem, in my opinion, with constructors of well, anything, but definitely in the STL, because I mean, if you look at different features in the STL and how to construct them, they all have about 12 or 14 arguments. That seems to be like the pain threshold of the committee before they start saying, well, no one's going to use that theoretically possible combination of arguments, right? Because again, we're fighting a quadratically growing problem with brute force, right? We're making, you know, for every one of these 5 different inputs, we are making that thing exists and that thing doesn't exist, right? And then taking away the ones that we think people might not want to use. And this will just get worse with ranges because, you know, we're adding a whole nother 1 or 2 things that could be that way or another way, right? So, I mean, we don't want the number of constructors to double. But if you think about the problem here, we can kind of cheat, right? So we can say, oops, sorry, I should have. Yeah, so this is the big fucking hammer solution, BFH, right? We compose the exact same thing again, just to initialize it correctly, right? Because if we're using the composition syntax, well, you know, we're just passing objects to a tuple here, So we can initialize them however we want. They don't need to be default initialized, although they were in all the other examples, right? And the type is that this is spitting out is the same that we defined up here, a shared pointer. And so, I think with guaranteed copy elision, you could even use like non-copyable types here. But that doesn't matter because it's ugly. So we could also use kind of a clever name parameter-y kind of a solution, make a variable template that spits us out a type with a copy constructor that returns whatever we want, and then within the constructor inside the composed type, we could then move index into the tuple what has this type and put it in there, right? And this is still a little bit problematic because we support multiple objects of the same type, but in this case it would work. It wouldn't work so well if we had like multiple parameters, because then the equals operator will only have one thing on the right-hand side, and the constructor may take multiple parameters. And so we could be less clever and then just make it some tuple thing that we're initializing with input. And oh no, wait, those shouldn't be curlies. This should be a factory function. Sorry, because otherwise the return type couldn't depend on. Well, in C++17, these could be curlies. No, sorry. So we can cheat our way out of this problem, and we have cheated our way out of a lot of problems. But I think there we're fighting with windmills again. We're fighting the wrong fight. I think the way we deal with combinations of arguments or combinations of input is somewhat wrong, because if you think about what we're doing when we're making all of those constructors, like we're following a very defined algorithm, right? Like, okay, every one of these things there can be 1 or 0 of. And then, okay, make permutations, right? We could express that programmatically, right? We could say, here are the components that need to go into this thing, and build them, right? And this is actually a talk that Gasper is going to hold in the future. I just decided this for him because he has awesome ideas in this field, which I think he calls production guidelines. So the metaphor is, the extreme metaphor. I have a function that takes a height and a width, and the user will often have height and aspect ratio, or width and aspect ratio. So I should be able to make some programmatically expressed deduction thing and be able to fall back to name parameters. And you can actually do that to a certain extent in TMP. We played around at C++ Now, or much more, Gasper played around with HANA to make that work to a certain extent. So he will do a talk on this in the future. Sorry, buddy. And this will be solved, and then we'll be able to solve shared pointer generically. And all of the other instances where people are trying to add things to them for one use case where we really should be thinking a lot more generically. So yeah, I wrote a little more than a PowerPoint presentation. There's also a buggy GitHub thing. So I'm going to drop a paper and declare victory like no, sorry. Yeah, so if you want to work with me on this or give feedback later, or you're watching the video, Odin the Nerd at everything. Or we can open up to questions for the people that are here. Yes?
So, how do you do
I think maybe to the mic, because then I don't have to repeat it.
So, there are clearly combinations that don't make sense, right? Like in your shared pointer example, what happens if you put 2 shared pointer value, was it the name of the thing that holds the pointer? Well, what will it do, right? Like it depends, I guess.
Both and delete them both at the end.
Well, it might be that it will be a bug, right? Because of how the interface delegates and how the other things.
Yes.
So how do you deal with these combinations that don't make sense or could be problematic?
Well, one of the other agents should be accessing that thing as a execute, as there is one of those, right? And that would be found. we have these, for each in the case where there could be multiple or optional or one single one. For a reason, we're not just accessing them, we're also in the same action expressing rules about what a valid set is, right? And yeah, this is something that I actually didn't put into the talk, but it's good that it's a question. It actually wasn't even planted. Yay! The main problem with this method of checking is that it's hard to prove that there will not be, this is the case, there will not be a multiple of one agent in the set, and no one is actually accessing that agent. You could have an agent that just consumes functionality and is found from the public interface in some way where it wouldn't be noticed or if you were expecting 2 and you get 3. That's the harder case, right? Because 0 or 1 are numbers. 2 is not a number, right? 2 is part of infinity, right? And so, yeah, there is some problem there. And the other thing is, these contracts between the agents are checked at the point where somebody makes that call to the public interface, right? Because as long as nothing is instantiated, nothing will fail, right? So if I make my shared pointer in an invalid set and then never call any member function, I'm not sure that that's bad because I never called any member function, but it is bad in the case where I do that and then somebody else in 10 years says, oh no, he should have called this member function, and then that exposes the fact way later that this is an invalid set. And there is a way to combat that. You could actually make public interfaces specify all of their functions or reflect on them in some future time in C++. But at this point, you make a list of references to all your member functions and put that in some tag. And then you could go through in an unevaluated context because you don't actually want to call them and pretend you called them, and then everything would be, yes, Casper?
If you do the type erasure thing, it will generate all
yes, type erasure will solve it, but you may also not be type erasing. But yeah, good point, because it will generate all the calls to all the public interface.
Cool.
Yeah, good question. Well, yes.
On the same note, or similar, did you look at using boost DI to solve the compose problem of what you pass into the different constructors of the different pieces?
No. I actually have not looked into boost DI at all. Is it even in boost yet? That's Chris
No.
Uziak's lib, right?
Yeah, it's still in experimental.
Does that not rely on, I think I saw a lightning talk of his, does that not rely on some virtual calls somewhere anyway?
I don't think so. I think you can turn off virtual calls completely in there.
Yeah. Okay, well, if he is doing it in a way that's viable, then he must be doing it in TMP, in which case we could use that. But that would then be probably just another flavor of some production guidelines, essentially. Mm-hmm. But yes, thank you for the tip. I will look at that. Anyone else? Yay, I have 2 minutes left to victory dance.